Okay, so our first project will be, it's going to load. We are going to do an egg drop. So I will go into some of the rules of the egg drop in just a few minutes, but we just know you will need an egg before the end of this project, and we will drop it from a height of about 6 feet. So our objective for this lesson is to identify the need for a specific engineering design project, describe the design project context, and identify and differentiate the design project constraints and requirements. So basically, we're going to start thinking and brainstorming about how to protect our egg. Some vocabulary you might hear me use today is constraint, a restriction on the degree of freedom one has in providing a solution. So I'm going to give you some rules. Those are your constraints. Engineering design loop, a specific iterative set of design steps that engineers use to evaluate and refine potential solutions and problems or challenges. The steps: ask and identify the need of constraints and research the problem, imagine possible solutions, plan by selecting the most promising solution, create a prototype, test and evaluate the prototype, and improve the design as needed. This is also called the engineering design process. Iterative. So iterative is basically anytime we change our project. So sometimes in our projects we need to make changes or find out that we need some more supports, or we just need to change our project in any way. That's all iterative means. Iteration and iterative are the same thing, and it just means when we're figuring things out, we have to make some changes. So that is what iterative is. Requirement: what particular product or service should do. It is a statement that identifies a necessary attribute, capability, characteristic, or quality. In engineering, the set of requirements are inputs to the design stages and product development. So we are developing a product. Now, this is not a product that would normally be for sale. I don't think anyone needs to be able to drop their egg from 6 feet high on a normal day. This is just a design constraint and requirements I have created for us. Why is this important to engineering? Scientists and engineers and ordinary people use problem solving each day to work out solutions to various problems. Using systematic and iterative or changeable procedure to solve the problem is efficient and provides a logical flow of knowledge and progress. What is the goal? Students will create a package to contain and successfully land a raw egg, unbroken from the fall to the ground. They will learn how velocity and acceleration from falling objects relate to a force on landing. Here are your rules. You only have two rules for the egg. 1, the egg cannot be strapped in. No seatbelts, no taping it to the side, just floating in whatever contraption you create. 2, the egg must be raw, no hard-boiled eggs. The next part is a bin. You're going to create a bin or holder that you can manipulate the box in any way. Be creative. And I named my egg Eggward. So how can I say the Eggward? The speed of gravity, about 9.8 meters per second. Gravity is measured by the acceleration that gives to freely falling objects. At Earth's surface, the acceleration of gravity is about 9.8 meters or 32 feet per second. Per second. Thus, for every second an object falls, its speed increases by about 9.8 meters per second. So again, it's going to go about 19.8 meters per second if you have it going for 2 seconds. So right here is an article, and I'm only going to read the first section. Okay. How does gravity pull things down to Earth? Gravity is a force, which means it pulls on things, but Earth is the only thing which has gravity. In fact, everything in the universe has its own polar gravity, even you. Isaac Newton was one of the first scientists to figure out the rules of how gravity behaves. Okay, so I'm going to skip down to here. First, we'll go to the park and play football. When you kick the football into the air, the Earth's gravity brings it back down. But that's not the only thing that's happening. The gravity of the football is also pulling on the Earth. The thing is, the Earth is very heavy, much heavier than the football. So it's unaffected by the pull of the football, while the football itself is being pulled back to Earth. Our next stop is the moon. As we journey into space, there's a good chance you'll see the sun. But okay, so I'm going to stop there. But again, it's that pull of gravity that is causing it to go 9.8 meters per second. And so here is the design process. Each day we will go through one piece of the process. So today we are asked, we know the constraints, we know the rules of this challenge. On Monday, we will start researching the problem. We're going to get some information about our egg and about the how speed and things travel and about gravity a little bit deeper to help us figure out what's going to protect our egg the best.